today we are going to learn about the transmission of the nerve impulse. Just I will take few minutes to revise and remind you about the structure of the exolemma and the exoplasm, right? If you guys remember, we learned that exolemma, it is obviously a lipid bilayer. There is sodium potassium pump. If you guys remember, we did discuss this yesterday, right? Then we also discussed that there are sodium leak channels. Let's suppose that this is what? This is the sodium leak channel, right? Then we discussed that there are potassium leak channels. Let's suppose that this one is what? A potassium leak channel, right? I'm drawing the potassium leak channels with the blue color, right? So these are what? These are the potassium leak channels. Then I told you guys that there are sodium voltage gated channels, right? So with the black color I drew the sodium voltage gated channels, and then there are potassium voltage gated channels. With the red color I am drawing the potassium voltage gated channels. The question is, why am I calling these channels as voltage gated channels? Because these channels, they only open or close on a certain voltage, certain change in the current, right? So if you guys remember, we discussed this yesterday, that let's suppose that on this side is the exoplasm and on this side is what? ECF, right? Now I also told you guys that there is sodium present in the exoplasm. There is sodium present in the ECF. Do you guys remember this or not? There are potassium ions present in the exoplasm. There are potassium ions present in the ECF. But I told you that the concentration of the potassium ions in the exoplasm is 30 times higher than the ECF. Remember this, right? And over here, it is 30 times low. I gave the example. If there are 30 potassium ions present in the exoplasm, there will be only one in the ECF, extracellular fluid. Right, Fazan? And I told you guys that sodium ions, they also have a gradient. The sodium ions are more in number outside. They are 10 times higher in the ECF. It means that they are 10 times lower in the exoplasm, right? Now, so this is the concentration gradient, that the potassium ions, they are higher in concentration in the exoplasm, and sodium ions, they are higher in concentration in the ECF. Now, let's label that this is what? Sodium potassium pump. This is sodium ion leak channel. I'm not writing the word channel. These both are potassium ion leak channels. This is sodium ion voltage gated channel, and these two are potassium ion voltage gated channels. If you guys remember, I told you guys this thing yesterday as well, that the number of, when we compare only the leak channels, the sodium leak channels are lesser in number as compared to potassium ions, right? Potassium ion leak channels are more in number. And if we compare the voltage gated channels, the sodium ion voltage gated channels, they are less in number, and potassium ion voltage gated channels are more in number. Now, over here we are only discussing about positive charges, but we know that electricity, now the nerve impulse is also called as electrical impulse, right? And we measure it in millivolts, and volt is the unit for electricity, you know that, right? So when we talk about electricity, we say flow of electrons is the electricity. So definitely there will be some negative charges which will be causing the current in our body. Now what are those negative charges? Now I told you yesterday that there are charged amino acids. We can call them as what? Polar amino acids. Right? There are bicarbonate ions. You can also call them as hydrogen carbonate ions, right? There are carbonate ions. There are chloride ions, and there are phosphate ions as well, right? So these are the negative charges. Now if you guys remember, yesterday I told you guys that all these negative charges, they are immovable. Means what? These charges cannot go in or come out. Only the sodium and potassium can go in or come out. Understand? Now, this is sodium potassium pump. Anyone knows its other name? This sodium potassium pump has another name. Anyone remembers that? Last year you guys learned about this. This is a carrier protein, sodium potassium ATPase complex, also called as sodium potassium ATPase complex. Now, so remember one thing, these negative charges are present in the ECF. These negative charges are also present in the exoplasm. Everyone understood till here? Now we are going to move forward toward the transmission of the nerve impulse. Now, before I start explaining this, I am going to draw a table and I am going to tell you the steps in the table which we are going to learn right now. I am going to make it easy for you, inshallah. Now, let me draw the graph over here. Now, this is the graph. This over here we have x-axis, right? And this over here we have y-axis. On x-axis we are taking time. And we are taking time in milliseconds. Taking time in milli. This nerve impulse travels very fast, if you guys remember, right? We learned that in the myelinated axons or myelinated neurons, the nerve impulse travels at 120 meters per second, right? So when the process which we are going to study right now in 1 hour, it's actually taking place in milliseconds, right? And on the y-axis, I am going to take millivolts. I am writing MV, right? Now, let's suppose over here, we draw a straight line. Let's suppose this is 0 millivolt. Now, if I will come down, it will be negative. If I go up, that will be what? Positive, right? Now, let me tell you that, now first of all I will draw the graph, right? Then you will understand everything, inshallah. Let's suppose that this value over here, this is minus 70 millivolt, right? Now what happens? And let's suppose that over here, this is plus 30 millivolt, this is plus 40, and it can go up. Now, if I draw the graph for one nerve impulse, it will appear like this. The graph for one nerve impulse will appear like this. Now, there is 1, 2, 3, 4 stages are there which we are going to study. First of all, at this minus 70 millivolt, this is referred as resting membrane potential. Now, this is the stage when no nerve impulse is passing. The question is, why no nerve impulse is passing? Can anyone answer this question? There is no stimulus. Obviously. Nerve impulse will only pass when there will be stimulus. When there is no stimulus, at that time, the nerve cells will be at what? Minus 70 millivolt. Now, I will explain you guys what is the meaning of minus 70 millivolt. Don't worry. We will start that. Next, what happens? Then the nerve impulse, you see, let's suppose a stimulus comes. But the stimulus must be of threshold level. Stimulus must be of threshold level. Now, let me mention over here with blue color. Let's suppose that over here, this is what? This is minus 55 millivolt. Now, let's suppose this is your friend. He's standing over here, right? What do? Sitting with you, you are trying to tease him. Once, no reaction. No reaction. Stimulus is not enough. Stimulus is not enough. I'm going to explain everything to you, inshallah. Third time when you do this, reaction is there. Means that when the stimulus came, what happened? That the change tried to happen, but the change was not enough to reach to minus 55. The change was not enough to cause the change in the charges to become minus 55. Stimulus died. The reaction will only start. The nerve impulse will only initiate if the charges reach to minus 55. Now, let me tell you, before that, from minus 70 up till plus 30, this is called as depolarization. What is it called? Depolarization. Now, question is, what do you mean by depolarization? Changing in charges. I'm going to explain that inshallah in detail. I said that I'm just going to tell you the points which we're going to study. Then from plus 30 it comes back towards what? Minus 70. This phenomenon is called as repolarization. But if you see, the graph went below minus 70 millivolt. Maybe it came up till what? Minus 80 millivolt. It can. Now this, when the graph goes below minus 70 millivolt, what was happening? Repolarization. It becomes hyperpolarization. What is it called? Hyperpolarization. But eventually, the graph came exactly at what? Minus 70 millivolts. So it means that it is reinstated to resting membrane potential. Means that the nerve impulse is now passed. Now, come over here. First of all, we are going to talk about what? Resting membrane potential. Now let's suppose that this is what? This is exolemma. Right? Now, remember one thing I told you yesterday. Electrons travel on the surface of the wire, not in the wire. If they will travel in the wire, there will be resistance. Same. This is the outer surface of the exolemma. Remember that this over here is the exoplasm. Remember this. And this over here is what? ECF. Right? And in the resting membrane potential, look over here, from here up till here, there is no stimulus. No nerve impulse is there, right? It means that there is no negative charge on the outside. At this moment, outside is positive. And inside is what? Negative. Remember, nerve impulse will only travel when outside of the exolemma will be negative. Remember, I just gave you the example. Electrons travel on the outer surface. The nerve impulse will travel when there is negative on the outside. Right? But in the resting membrane potential, it is positive on the outside, so it means there is no nerve impulse. Negative is on the inside. Now, when I am saying negative on the inside and I am saying negative 70 millivolt, so which side I am representing? Excellent. Inside. So it means that this is minus 70 millivolt on the inside. Minus 70 millivolt on the inside. Understood, everyone? Now, remember one thing. I told you guys that these are leak channels. Leak channels are always leaking. They are not closed at any time. It means that through the leak channels, sodium will always be moving from higher concentration to lower concentration. Now we know that sodium concentration is higher in the ECF and lower in the exoplasm. So sodium will keep on leaking from here to here. From higher concentration to lower concentration. Understood? Sorry? Yes. Leak channels, they are always open. Keep this in mind. Sodium or potassium, both are leak channels. They are always open. They never close. As they are always open, and they help in facilitated diffusion. Right? Whenever things are moving from higher concentration to lower concentration, using the channel proteins, that is called what? Facilitated diffusion. We have learned that, right? So sodium ions will be moving from outside to inside, from higher concentration to lower concentration, and we know that inside the exoplasm, potassium ion concentration is what? Higher. So potassium ions, they will be moving from the inside to the outside, where the concentration is what? Low. Now, so what is happening? That sodium and potassium, they are going, right? Moving according to their concentration gradient. Now what should happen? That most of the potassium should leak out, right? But it does not happen. It does not happen. Why most of the potassium cannot leak out? The reason is the presence of these negative charges. Presence of these negative charges. Negative and positive, what do? They attract each other. Understand? So because of the attraction between these negative charges and the potassium, not all the potassium will be leaked out. It will be retained as well inside, but there is still concentration gradient, so potassium will be coming out. As you guys know, 30%, 30 times more concentration. So potassium is coming out. Outside is remaining what? Positive. Positive charges are coming out. Remember, one more thing, very important thing. Whenever we will talk about charges, we will talk about overall charges. We will talk about what? Oh, there will be positive charges, there will be negative charges. If the negative charges will become more in concentration, it will become negative. It will become overall negative. If the positive charges will increase in number, overall charge will become what? Positive. Understand? So keep this in mind. It is about overall charges. Right? So remember this, that over here, this is what? Sodium ion leak channel. These two are what? Potassium ion leak channels. Right? This is sodium ion voltage gated channel, and these are potassium ion voltage gated channel, and over here, which color is left? Let's use the black color again to draw. Sodium potassium pump, right? Very quickly, sodium ion leak channel, potassium ion leak, sodium ion voltage gated, potassium ion voltage gated, and sodium potassium pump. Now, from now to onward, I will not discuss these three channels. Why? They are always open. They are always open. And sodium ions are moving from higher concentration to lower concentration. Potassium ions are moving from higher concentration to lower concentration. And potassium ions will be moving more. Can you tell the reason why potassium ions can move more? More channels. One reason. There is another reason. 2 marks question can come. More higher gradient difference. 30 times. Sodium is what? You have learned that diffusion last year or not in detail? If there is a more concentration gradient, more faster diffusion, right? So potassium ions, they can diffuse more because of 2 reasons. More number of potassium ion channels and higher concentration gradient. Now, what did I say? That we will not discuss these 3 from now on forward, right? Now, during resting membrane potential, they remain closed. These are going to be your notes as well for answering questions. The points. First point, during resting membrane potential, sodium ion voltage channels, they remain closed. Potassium ion voltage channels, they remain closed. Voltage gated channels, they remain closed. Right? So only movement of ions is taking place through leak channels. But what happens? Sodium potassium pump is working. So what the sodium potassium pump will be doing? Now, it is performing active transport, right? So what it will be doing? It will be pumping 2 potassium ions inward and 3 sodium ions outward. Outside concentration is high. Inside is what? Low. From inside to the outside. 3 sodium ions pumped outward. 2 potassium ions pumped inward. Now if you see, what is happening? More of the potassium is coming out because more number of potassium ion channels. Understand? And sodium is also being pumped out by the sodium potassium pump. Right? So what will happen? Overall, there will be more positive charges on the outside. as compared to negative charges. Because of that, what will happen? Outside will become more positive, inside will become less positive. It will become negative. Understood? So let me mention over here that as there are more number of potassium ion leak channels, so more potassium ions leak out. And what was the second point? Higher difference of the higher concentration gradient. For potassium ions. So more and more potassium will come out, right? So as a lot of potassium is coming out, even sodium is being pumped out by what? Sodium potassium pump. It will cause an overall positive charge on the outside and overall negative charge on the inside. And this is a time when there is no nerve impulse. Now, what happened? Poke. The poke that generated the nerve impulse. Now, if you guys remember, yesterday I told you that there are another type of sodium channels. What are they called? I am showing them like this. Very good. Mechanical sodium ion channels. What are they? Mechanical sodium ion channels. Now we are going to talk about what? Depolarization. Now, action potential or depolarization, they are same thing. Now, what is the meaning of action potential? Action potential means when the nerve impulse will be generated, and generation of the nerve impulse happens because of depolarization. Now, simple. Depolarization means shifting of charges. Depolarization means shifting of charges. Now, before it was positive on the outside. Now, when the depolarization will happen, it will become negative on the outside and positive on the inside. So the charges have been shifted. Outside became negative, inside became positive. We will call it as what? Depolarization. Now, question is, how did this happen? How did it become overall more negative on the outside? Remember, always this is overall more negative. How did it become? Remember, I told you we will not discuss these ones. We will only discuss these things. Now, when there was a poke, poke is a physical pressure, right? I'm explaining you for the example, for understanding this, right? This is not in your syllabus, this is not mentioned in your book, but for your understanding, I'm telling you that. Otherwise, you will not understand this example, right? When there is pressure applied, these mechanical sodium channels, they will open. Because of pressure, mechanical sodium channels, they will open. Now, these channels are now open, so sodium will move from what? From where? From outside to the, from higher concentration to lower concentration. Now, when the sodium will move from higher concentration to lower concentration, so inside will start becoming what? More positive. It means that inside it will not remain minus 70 anymore. It will not remain minus 70 anymore. It will start going towards the zero. And so many mechanical sodium channels are open that maybe it reaches to what? Minus 55. Maybe it reaches to minus 55. Now, minus 55 millivolt on the inside causes the opening of sodium channels, sodium voltage gated channels. Now, please pay attention. So again, this is what? Exolemma. Remember that. What is this? Exolemma. Let's suppose this is sodium ion voltage gated channel, right? And these are potassium ion voltage gated channels. Right? Now, what did I tell you guys? When you applied a pressure, you gave a stimulus. Because of that, mechanical sodium ions channel they opened, and they allowed the entry of the sodium ions from here to here. Now, inside was before what? Negative. It started changing into what? Positive. Because influx of sodium ions. Because of influx of the sodium ions. And when it reaches to what? Minus 55. Now minus 55 is the electrical potential where sodium ion voltage gated channels they open. They open at what? Minus 55 millivolt. Now what? Just a minute. Just a minute. I'll take your question. Just a minute. Now when these sodium ion voltage gated channels they will open, they will allow the movement of what? Sodium ions from higher concentration to lower concentration. From higher concentration to lower concentration. During this time, potassium voltage gated channels they remain what? Closed. Understand? Another thing happens. The sodium potassium pump, let me draw over here. It becomes closed. I'm going to write these points down, don't worry. First, let me explain this. Now, what has happened? Potassium voltage gated channels did not open. Right? So it means that potassium is not coming out. Rather, what is happening? That sodium influx has increased from outside to inside. Now, sodium is going from normal leak channels from higher concentration to lower concentration. Now, voltage gated channels of the sodium has also opened. Now, what will happen? Sodium has started moving from higher concentration to what? Lower concentration. So much sodium will go inside. So much sodium will go inside that what will happen? That inside will become positive and outside will become what? Negative. And internal, it will become what? Plus 30 millivolt. Remember I told you, these charges or this, you see, current which we are discussing, that is inside the side, inner side of the exoplasm. Exolemma, not the outer surface. Not the outer surface. Now let me write these points, then I will talk to you, okay? First point, what did we discuss? That sodium voltage gated channels, they open. Potassium ion voltage gated channels, they remain closed, and sodium potassium pump stops working. Now just imagine, sodium potassium pump was pumping 3 sodium outward. It's not pumping anymore. Sodium is staying inside. Sodium is staying inside. And sodium is going inside through sodium voltage gated channels. Sodium is also going through sodium leak channels. So inside is becoming what? Positive, positive, positive. And as so many positive charges will go inside, overall it will become what? Negative on the outside. Now what has happened? Nerve impulse has started traveling. Now you understand this or not? Right? And this negative charges are because of what? Because of these, which are not moving, because there are no channel proteins for them. I explained you that yesterday. Got it? Now, the peak, in some books it's mentioned plus 30 millivolt. In some books it's mentioned plus 40 millivolt. Now, why there are different values in different books, and even the threshold value is mentioned in some books as minus 60 millivolt, in some books it is mentioned minus 55, in some books it is mentioned minus 50 millivolts. Now it depends on different types of stimulus, right? And different type of the, you see, the center of the brain where the stimulus is going, right? And even on different type of different persons as well. Now your threshold level can be different for me, right? Maybe I can bear more pain, maybe you can bear less pain, right? So the threshold can be different for different people, right? But the average or the mostly mentioned in the books is what? Minus 55 millivolt, right? Understood everyone? So what happens? Sodium potassium pump stopped. Sodium stays inside. Potassium voltage gated channels remain closed. Potassium stays inside, right? Sodium voltage gated channels open. Sodium goes inside. Sodium leak channels, sodium going inside. Understand? So many sodium inside, and potassium already remained inside. Positive charge on the inside and becomes negative on the outer side. Yes.
So can't the sodium potassium pump work backwards?
No. They have. You see, they have a direction because it is active transport. It is active transport. Lower concentration to higher concentration. Got it? Yes.
So there is no use of potassium voltage channel.
There is use, sir. We are here. Did we finish? Now we are going towards what? Repolarization. Everything has a use. Right? Now, yes.
Sir, when the pressure sodium pump, when it closes, the energy concentration inside is higher, right?
Yes.
Sir, so how does the energy?
But still outside it is, still outside it remains higher than inside. Alright? Eventually, you see, so many sodium going inside, but still it remains outside higher. The gradient will become lesser, but still it will remain higher outside. Alright?
So same applies for the mechanical sodium?
Yes. Alright? Because sodium is only moving by facilitated diffusion. Alright? Now, boys, we are going to talk about what? Repolarization. Once the nerve pulse is generated, that section of the neuron has to come back to its original position. That section of the neuron which was excited has to come back to its original position. Why? So that another nerve impulse should pass there. So that another nerve impulse can pass from there. For that purpose, what should happen? Repolarization. Now, I am going to mention repolarization. I am going to rub from here. Alright? Now, please pay attention. Now we are going to discuss repolarization. Now, repolarization means what? Returning the original charge. Returning the original charge means that outside should become what? Positive, and inside should become what? Negative. Outside should become positive and inside should become negative. That is called repolarization. Now, how this will take place? Again, please pay attention. Again, remember that this is what? This is exolemma, right? Over here we have exoplasm. Here we have ECF, right? And remember, we have what? This is sodium ion voltage gated channel, right? And these are potassium ion voltage gated channel. I'm not writing the complete words, but whenever you are writing the detail, you have to write complete voltage gated channel, right? Now, I told you that sodium ion voltage gated channel, they open at what? Minus 55 millivolt. They close at plus 30 millivolt. Sodium ion voltage gated channels, they close when it reaches to plus 30 or plus 40, right? Now when the sodium ion voltage gated channels will close, what will happen? Influx of the sodium will what? Stop. Influx of the sodium will stop. And this plus 30 millivolt is the sign for what? For the potassium voltage gated channels to open. Remember, I told you these voltage gated channels, they open at a certain voltage. So what will happen now? Potassium voltage gated channels, they open.
Sir,
Yes.
at which voltage does the sodium voltage open? The sodium
Minus 55. I just explained that. Right? So at minus 55, sodium voltage gated channels open, and sodium voltage gated channels, they close at what? Plus 30. Remember that. And at plus 30, potassium voltage gated channels, they open. Another thing will happen. At this stage, sodium potassium pump starts working. Sodium potassium pump starts working. Now outside should be more positive, inside should be more negative. Remember this. Now what will happen? Sodium voltage gated channels are what? Closed. Look here. Closed. Sodium can't go inside. Sodium will remain outside, right? Now, potassium inside is higher in concentration, will start flowing where? Outward. From 30 times higher to the 30 times lower. Understand? And sodium potassium pump has also started working, which is pumping 3 sodiums outside. Influx of positive charges, right? Potassium coming outside, sodium coming outside by sodium potassium pump, and sodium can't leave because sodium channels are now what? Closed. So the positive charges are now accumulated on the outer side. So it will become what? Overall positive on the outside and overall negative on the inside. So repolarization takes place. But there is a problem. One thing. We discuss what? Hyperpolarization. It does not remain minus 70 on the inside. I said it may become minus 80 millivolt. It may become minus 80 millivolt. Let me mention hyperpolarization. Now, why did it shoot towards minus 80? No. The thing is that potassium voltage gated channels are higher in number as compared to sodium, right? And second thing, that the difference of the concentration is very high. So it takes a bit longer time for the potassium voltage gated channels to close them all, right? So there will be overflow of the potassium ions than requirement. Understand? So during the hyperpolarization, what happens? That potassium ion voltage gated channels take time to shut down, Because they are more in number, right? And more concentration gradient. So what happens? Excess flow of potassium ion causes hyperpolarization, right? Now, what should happen? The hyperpolarization did take place, right? It became at minus 80 millivolt. Nerve impulse cannot pass until or unless it goes back to where? Minus 70. Means that there must be reinstatement of resting membrane potential. It should go back to where? In this stage. When there is what? Minus 70 millivolt. Now what will happen? Sodium voltage gated channels, they will remain closed. Potassium voltage gated channels, they opened, they will also close. Right? Remember, you see, when repolarization took place, after the repolarization is completed, then reinstatement of the resting membrane potential. Now where should I write that? Up.
Yes, sir.
Now, so last step is reinstating resting membrane potential. I wrote RMP. It means resting membrane potential. Now, during the reinstatement of the resting membrane potential, sodium ion voltage gated channels, they remain closed, right? Potassium ion voltage gated channels, they also close. Understand? And what happens? Sodium potassium pump keeps working. Understand? So what will happen eventually? That the resting membrane potential will be reinstated. It will come back to minus 70 millivolt. Now, whole process is complete. Now, as it has reached to minus 70 millivolt now another nerve impulse can pass. If another stimulus comes of the threshold level, Now, there are two more very important things which we need to discuss. One is refractory period. And this is absolute refractory period. And second thing which we need to discuss, that is the relative refractory period. Now, what is absolute refractory period? Please pay attention. Not difficult, very easy thing.
Yes. Can I ask a question for that?
Yes.
When it goes from plus 30 to minus 70, doesn't it go through minus 55? So like during that time, doesn't the sodium channel open? What's the channel?
From here to here.
No, from plus 30 to minus 70. So it goes through minus 55.
It's asking like,
So that is repolarization. Sodium voltage gated channels are closed.
Isn't it supposed to open at minus 55? Doesn't it open
No,
during that
no,
time?
no. Because it is repolarized. It has to go back to original position. Minus 70.
So while going back, it passes minus 55 as well.
Yes.
So why the gate not open?
Yes. Because it has to, its original position was what? Minus 70. It has to go there to the resting membrane potential so that another nerve impulse can be generated. Alright? Now please pay attention. Look here. from here till here. From here till here. No, you see, a nerve impulse is passing from this point to this point in milliseconds. The nerve impulse is what? Passing. During this, another nerve impulse cannot be generated. That is called absolute refractory period. Now, question is, why another nerve impulse can't be generated? Because what has happened during this, you see, during action potential, sodium voltage gated channels, they are already open, right? Potassium voltage gated channels, they are closed. Sodium potassium pump is what? Working. So it is already depolarized. So once it is already depolarized, another nerve impulse cannot be passed. Another nerve impulse can only pass when it is repolarized. Understand? So from here till here, this is the time period no nerve impulse can pass at all. And that time period is called refractory period. Now question is, what is relative refractory period? Now relative refractory period is from here till here. From hyperpolarization to resting membrane potential. From hyperpolarization to resting membrane potential. Now hyperpolarization, it is at minus 80 millivolt, right? Now if the threshold level is so high that so many sodium mechanical channels open that it can reach to minus 55. Now reaching from minus 70 to minus 55 is easier. But reaching from minus 80 to minus 55 is what? Difficult to achieve. Understand? So that is why when it is hyperpolarization, nerve impulse cannot pass until or unless stimulus is very, very high. Understand? So many of the sodium channels, they are open, right? So that the change in the charges becomes minus 80 to minus 55. That is why it is called relative refractory period. Can pass, but under very strict conditions. Here, not at all. Whatever happens, nerve impulse cannot pass. Understand? Now, just leave that example. Understood, everyone? Yes. Now, very quickly, just give me a few minutes. I'm going to repeat this all. Sorry? No.
We don't think about it.
So we can replay the video.
Yes. No, but you see, a very quick review. Remember, we know that this is exolemma. Exoplasm on the inside, ECF on the outside. There is sodium potassium pump. There are sodium leak channel, potassium leak channels. Potassium leak channels more in number. There are sodium voltage gated channels, potassium voltage gated channels. Potassium voltage gated channels more in number. Potassium 30 times more inside, 30 times less outside. Sodium 10 times more outside, 10 times less inside. Then there are negative charges, we have discussed that. We discussed that there are 1, 2, 3, 4 stages, right? Rather 5. Reinstation of the resting membrane potential. Resting membrane potential is what? Minus 70 millivolt, and I told you that is the inside of the exolemma. Over here, right? It remains minus 70 on the inside and plus 70 on the outside. The current only travels when it is negative on the outside, right? A joke at the end as well. So stay tuned. Sodium voltage channels, they remain closed during the resting membrane potential. Potassium voltage gated channels also remain closed. While the sodium potassium pump keeps on working, pumping 3 sodium outside, right? Keeping outside positive. And remember, I told you we will not discuss the leak channels because they are always working. Doesn't matter to talk about them, right? Because of this, what happens? Overall charge outside remains positive, inside becomes overall negative. When the stimulus comes, which is of threshold level, what is the threshold level? which can change and press mechanical channels, that so much sodium goes inside that it becomes minus 55 on the inside. When it becomes minus 55, that minus 55 volt is the sign for the sodium voltage gated channels to open. Sodium voltage gated channels, they will become open. Sodium influx will start from higher concentration to lower concentration. Potassium voltage gated channels, they will remain closed. Means potassium will stuck inside. Sodium potassium pump will stop. Sodium is stuck inside. So what is happening? Positive charges are being accumulated on the inside. Inside becomes overall positive, outside becomes overall negative. Now we must translate it. But it must come back to its original position. So what happens? Repolarization. For repolarization, when it reaches to plus 30 millivolt, that is the sign for sodium voltage gated channels to close. But the sign for the potassium voltage gated channels to open. When it reaches to plus, you see this potassium voltage gated channels open, the potassium starts moving from higher concentration to lower concentration. And sodium potassium pump keeps on working, pumping the sodium outside, making outside positive, inside negative. But so many these potassium voltage gated channels are there that they take time. Now the sign for the potassium voltage gated channel is to close is what? Minus 70 millivolt. The sign for the potassium voltage gated channel to close is what? Minus 70 millivolt. They close, but they take some time because they are more in number. So the charge become more negative what? On the inside. Because positive charges are leaked outside, right? So it becomes negative on the inside. That is because of excess flow of potassium ions. Then it must be reinstated. And reinstatation, how happens? Sodium voltage gated channel remain closed. Potassium channels remain closed. Only thing is working, that is the sodium potassium pump. And it is reinstated. Right? Now the joke part. And you see this is repeated itself, right? Now in the next class we will talk about how it moves in patches. You see, I just told you that it is electrical impulse, negative charges. Very famous Pakistani scientist. Maybe you know her or maybe not. Anjuman, you know? She said in her poetry, Bijli bari hai mere ang ang mein. So she said in her poetry, but it is true that current is running in your body or not? Right? And in millivolts. But still there is current running in your body.